This is the sound of the Falcon Heavy taking off from Kennedy Space Center, Pad 39A. It is reasonable to assume that it is somewhat noisy, as 27 Merlin engines are working to generate 5.5 million pounds of thrust. With rockets this powerful, the sound energy generated by the engines can really cause significant harm to both the rocket and the nearby structures. We will examine NASA's approach to mitigating some of the sound damage in this video. We'll also examine how the Russians approach this issue in a distinctive way. Fire-hot gas is released into the flame trench by the rocket's engine as it lifts off the launch pad. The engines emit a great deal of sound energy in addition to their amazing heat energy. NASA reports that the Saturn V's sound level during liftoff was about 220 decibels. It would kill you if you were near the engines, not simply cause your eardrums to burst. The sound energy generated by the engines during the inaugural Space Shuttle flight, STS-1, was strong enough to harm portions of the shuttle's protective thermal panels. Despite NASA's previous usage of sound suppression technologies, the shuttle's distinctive design and delicate thermal shield made it more likely to harm the rocket or endanger the crew. NASA found a solution to this issue by installing a more efficient sound suppression technology to prevent harm to the vehicle or endangerment of the crew. This includes a huge water tower that discharges more than 1 million pounds at the launch location, in 40 seconds of water onto the launch pad. When sound waves collide with water, they are absorbed by constricting air bubbles and become heated, converting the sound energy into thermal energy. To further reduce the shock waves, NASA also placed water bags at the base of the SRBs in addition to this massive water spray. Across the SRB flame holes were big nylon bags that were filled with water and measured roughly 1 foot in width and 1 foot in depth. These two devices work together to lower the space shuttle's sound level from 195 decibels to a more reasonable 142 decibels, which is the same as a jet taking off. We truly get a sense of how much water is consumed during a sound suppression test, even though it can be challenging to observe the water deluge system in operation. Dropping this much water onto the launch pad prevents any fires from the rocket's exhaust, in addition to shielding the rocket and surrounding structures from powerful shock waves. All of NASA's major launch locations still employ a very identical water deluge system today. On the other hand, the Russians use a different strategy. Given that many Russian Soyuz rockets are launched from Baikonur, Kazakhstan, where winter temperatures can drop to -40 degrees, a water deluge system would quickly freeze up and be of little value. Simply hanging the rocket over a considerably wider flame trench is their answer. This indicates that not much stands in the way of the shock waves reflecting or causing damage. Going back to the rocket, it's fascinating to note that some issues can be resolved with relatively basic methods, even though rocket science handles some of the most difficult engineering difficulties. Please use the comments section below to ask any queries you may have. As we continue to discover more about everything related to space, make sure you're subscribed so you can participate in the conversation. If you like this video and would want to support the Space Haven, thank you for seeing, and I hope to see you in the next video.